so now we finish up learning this question, okay, doing this question, okay, eventually we want to graph it, right? So C of x equals x to the 4 thirds plus 4 times x to the 1 third. How to graph it? What we know so far is the domain is all real numbers because, see, this is a cube root, right? Cube root. So there's no restriction for x, so domain is all real numbers. And we did the first order derivative already. I'm not going to repeat those, okay? And then number C, we're going to find intervals where the function is concave upward or concave down. What should we do? We need to find the second order derivative, C prime prime, okay? So from the C prime equals this. We're going to differentiate so we can get C prime prime, right? So differentiate that, give us what? 4 thirds times by 1 third x to the negative 2 thirds, right? You guys, okay? And plus what? 4 thirds times by negative 2 thirds times by negative x to the what? Negative 5 thirds. By using power rule, right? Power rule.
Why is it times 1/3 x instead of times negative 2/3 x?
Because this 4 thirds comes from the given 4 thirds. And then by using power rule, we should have a negative 2 thirds times by x to the negative 2 thirds minus 1 give us negative 5 over 3, right?
Okay.
And then, see, these two, multiply back together, give us the 4 9ths, x to the negative 2 thirds. These two numbers times back together give us negative 8 over 9, okay, x to the negative 5 over 3. Okay, so we want to make this to be 0 where it does not exist. So I start to see, okay, this is the tricky part, how to handle these x, okay? Well, you see that for both of these two terms, we have something divided by what? 9, right? So I would say 1/9 is a common factor from both of these two terms, right? So I will factor out the 9s, okay? And see, from this term we have a 4, this term we have 8, right? So I factor out the 4 because 8 is a multiple of 4, so, right? So 4 is a factor of 8. And then this term we have extra something, this term we have extra something. Now let me ask you, for negative 1 is 2 thirds and negative 5 over 3, which number is a smaller number? If we want to put two numbers on the number line, which one we should put it on the left? Negative 5 thirds or negative 2 thirds? Negative 5 over 3 is less, okay? So we will factor out x to the negative 5 over 3 out. Let me give you one example why we're doing the x to the number. This number is a smaller number. Okay, see the example, guys. Do you know how to factor this? 4 out of 9, right? Also, we factor out what? X. It gives us what? X times by x gives us square, right? And then 4 9ths times by what? 2 give us 8 9ths. And x times 1 give us what? The x, right? You know how to factor this? Then why we're factoring the x out but not factoring the x squared out? Because 1 is a smaller exponent, right? We can only factor some factor which has a smaller exponent. You guys get that? We factor x out, give us x minus 2, right? Same thing here. When we are having negative 2 thirds and negative 5 thirds, it's so hard to know which exponent we should factor out. But because we know negative 5 thirds is smaller than negative 2 thirds, so we factor the term with a smaller exponent. Okay, always like this, okay? We're not factoring the x that has a bigger exponent. We are factoring out the x with a smaller exponent, okay? Now let's see what will be left in the parentheses. Yeah, x minus 2. 4 over 9 x negative 5 over 3 times by what equals x to the negative 2 thirds? negative 5 over 3 plus what equals negative 2 over 3?
1.
Yeah, should be 3 over 3, right, or 1? Right? Now from this term, we factor out the 4 over 9 x to the negative 5 over 3, so we don't have to worry about the x. However, we have to pay attention to that. Oh, this times by negative 2 gave us this. Right? You guys see what's going? Now we're having a very neat conclusion. This is negative 5 over 3. I will rewrite this as 4 times by x minus 2 divided by 9 times by x to the what? Positive 5/3. Or you can rewrite this as cube root of x to the 5th. Either way. Okay. Now there's no negative exponent. There's this looks very very neat, right? Alright, now this is our C prime prime. Okay, so if we know the C prime prime, what do we do? Just like when we find the critical numbers for C prime, what do? We're going to let C prime prime equal 0, and we let C prime prime does not exist. That will give us the special numbers for C prime prime. Okay, I'm not talking about this as a critical number, because critical number only refers to what? First order derivative. Now for the second order derivative, we just call these are special values of x. Okay, alright, so if C prime prime of x equals 0, it will imply x equals what, guys? X minus 2 equals 0 give us x equals what? 2. If C prime prime of x does not exist, it will imply what? Denominator equals 0, right? So if x has to be what? 0. Okay, so x will be 0. Now we're going to put these numbers, two numbers, on the real number line. Okay, 0 here, 2 there. Okay, so I just want to make sure that this is consistent. Okay, so 0 and 2. Okay, and 2. Okay, 0 and 2. So this is for what? Yeah, for x. Okay, and then vertical is for C prime prime. Okay, so 3 intervals. Okay, negative infinity to 0, 0 to 2, 2 to what? Infinity, right? You guys. Now key values or key numbers. On this interval, what key numbers do you want to choose? Negative 1. Okay, we can do that. Between 1 and 3. And then let's see, for C prime prime of x, what will be the sign for C prime prime? If we plug in x by negative 1, positive, this is negative 1, this is negative 1, right? Negative 1 minus 2, negative, minus 4, negative. How about negative 1 to the 5/3 power? Odd number, right? We'll still have negative 1. Okay? Equals cube root of negative 1 to the 5th. What is this? What is negative 1 to the 5th power? What's cube root of negative 1? Negative 1. So that means because this is an odd number, okay, odd number, okay, 503, it's not an odd number, but it's odd. So negative 1 to the odd power is always negative 1, okay? So negative over negative gives us what? Positive. So that means on this interval, our curve C, our function C should be what? Concave upward. Yes, concave upward. Okay. Now let's see, on this interval, x equals 1. 1 minus 2 negative, so top is not negative. On the bottom is 1, right? It's positive, so negative. Okay, so on this interval, we should have what? Concave downward growth, right? And then x equals 3, this is 3, so positive on the top, positive on the bottom, so it's positive on the entire interval, right? So we have concave upward graph. Right, you guys? Alright, you see, these are the, so we can say, okay, so we are going to answer the question like this, okay? So function C is concave upward on what interval? From negative infinity to 0 and what? 2 to infinity, right? And C is what? Concave downward on what interval? 0 to 2. Right? This is question C, right? Question C. Now question B. Use what? Use the information from all of the previous parts to sketch the graph of the function, okay? So let's try to sketch the graph of the function. Okay, all the numbers for domain, so there's no restriction. I'm gonna draw a system. Okay, so let's mark something, okay? -1, -2, -3, -4, 0. One, 2, 3, 4, 5, 8. And so on, okay, yeah. -3, -4, and so on, okay. So, domain only numbers, no restriction, and also, we always need some key points, right? Key values, okay? What are the key values?
1 is pushed by -1, -3.
Yeah, that one is 1, right? So we come back there, okay, so where is it? -1, well, x equals -1, y equals -3, right? So that's one key point, very good, we found it already. Also, the key point, we can always think about what? Intercepts. You remember x-intercept, y-intercepts, okay? So, to find x-intercept, we let y equals 0, right? So let the c equals 0, find x, okay, x will be 0. And then to find y-intercept, we let x equals 0, we find the c value, right? So you will see the x and the y-intercept will be what? 0, 0. Or we can do what? C of 0 equals what? 0. So 0, 0 will be one key point, right? Key points. Okay. And then we need more key points, right? We want to have, more, okay. Before we do the key points, let's look at what we found from the previous part. The function should be decreasing when x is less than -1. And then, I was wrong. Yeah. C of 0, 0 is the y-intercept if we replace x by 0. Okay, so this is y-intercept. Means the graph will pass through a region when it crosses or passes x-axis. Okay, so how do you find the x-intercept? We need to let c equal 0 and find x, right? So we let c equal 0, which is this equals 0. Let's solve for x. Okay, so let's see what we can get. Okay, so that you're right. Let c equals 0, and then let's solve for x. Those x values will be the x-intercept, right? So how to solve for x from this equation? Factor out x to the what? 4/3 or 1/3. Always choose a smaller exponent, right? Factor out x to the 1/3.
Restore the original.
X plus 4 equals 0. So this will give us x either what x to the 1/3 equals 0, which is x equals 0, or x equals what? -4. So x-intercept, there are how many of them? 2 of them. Okay. So will x equals 0 or x equals what? -4. So -4, 0 is x-intercept. X equals 0 is x-intercept. Y-intercept is also 0, 0. Okay. You guys, what's good about these 3 key points? Now our graph is decreasing when x is less than 1, -1, and increasing when x is what? Greater than -1. Okay, guys? Can you imagine the graph when x is less than -1? It is decreasing, and it must pass this key point -4, 0. It must, the graph must pass through this point -1, -3, and we know this is going to be local minimum. Means when x is greater than -1, the graph will goes up, right? It says x is between -1 to 0, it's increasing. And when x is greater than 0, it's keep on increasing, okay? So between when x equals -1 to x equals 0, it increases, okay? And then from 0 to 1, so this is between -1 to 0, and when x is greater than 0, it will keep on what? Increasing, right? Keep on increasing. Okay. Well, let's look at the concavity. Okay, we're not done for question C yet. This we only talked about what? Concave upward or downward, right? On these intervals. Remember, how do we define the inflection points? If f is continuous and changes from upward to downward or from downward to upward, that point on the graph is called inflection point. Now I'm asking you, do we have any inflection point on our graph? Change from upward to downward when x equals 0. So we'll have what? C will have inflection points or points. See here, when x equals 0, what is the c value when x equals 0? What is the c value when x equals 0? 0, right? So inflection point is 0, 0, and when x equals 2, change, right? Concavity changes. So when x equals 2, okay, what is the corresponding y value? Can you compute the corresponding y value? X equals 2, original function, so we should have what? 2 to the cube root, right? Times by what? 2 plus 4 give us what? 6, right? So 6 times by cube root of 2. Yeah, you may also, use a calculator and get a decimal number if you want to, okay? So I would say this point 2 and 6 times by cube root of 2 is
about 7.55.
7.55. Okay, so these are the two inflection points. Okay, so that means, okay, see, when x is less than 0, we have concave upward. Then from what? This interval 0 to 2, graph will be what? Concave downward, okay, on this interval, okay? So where is the key? This is key point 2, 6, cube root and 2. 7.55, right? So this is the point 2, 6 and the cube root of 2, which is about 6.55, right? So that means between this interval 0 to 2, we'll have concave downward graph. You can also, if you want to try another key point, say you can do C of 1, okay, because you don't know where is when x equals 1, where is C. You can try that. That gives us a 5. Okay. Oh, it is here. Right? So this is so far, okay? And then when x is greater than 2, graph will what? Concave upward. What goes that way? Yeah, concave upward. Okay, and we can also know that when x is greater than -1, it's keep on increasing. Okay, there's no decreasing, so that means it's keep on increasing. Okay, so start from here, concave upward increasing. We should have graph looks like this. Okay, or if you do know what's going to happen, x is greater than 2, you can try more key value to check. So you can do C of 3. Replace x as 3 and you find C, blah blah. I don't know what value it is, but I know the tendency of the graph should look like this. It's going to be concave upward and increasing. So, and see, there's no limitation for x, right? So that means the mean for x is all numbers satisfy all of these requirements, right? Decreasing, increasing, concave upward, concave downward, concave upward, right? So satisfy all of the conditions. So this is a final graph for the function C. You guys, that's good, everybody? And then we have, this is an inflection point, right? Turn upward to downward. This point is also an inflection point from downward to upward. And also we have what? Critical numbers, right? When x equals less than 1, it gives us a local minimum value, but it will not have local maximum. Alright, so this is question 2 from the last question from section 4.3.